Hello everyone, hope you all are doing well. I, Mahesh Fogart, welcomes you to the lecture series for the subject of automotive manufacturing processes and technology. Here we will be discussing things about unit number 3, that is the forming and shaping processes. So just download this lecture series and it will help you out to understand this chapter more clearly. And if you are having any doubts, you can contact me on my cell number. So let us begin with our first lecture. Now, before moving ahead, there are few terminologies which will come in your way while discussing these lectures. So, few of them are mentioned here, out of which first is the deformation. What do you mean by deformation? So, deformation means whenever any kind of load is been applied on the metal, on the specimen, so that will change the shape of the material. That load will change the shape of the material. This change in shape is called as the deformation. Now, this deformation, when it is a temporary one, that means temporary means, let us say you are applying the load, there is a change in the shape which is called as deformation. Now when you remove that load, the component, the specimen will come back to its original shape. This kind of deformation is called as the elastic deformation. That means it is a self-reversing one. You apply the load, it will deform, the material will deform. Once you remove the load, the material will return back to its original shape. This is called as the elastic deformation. Okay. Third one is the plastic deformation. That means it will not come back to its original shape. That means it has deformed permanently. So when the stress is sufficient to permanently deform the metal, this is called as the plastic deformation. So this is just a brief, you can say, understanding about these three terminologies. In detail, you should be aware of about the stress strain graph, which tells you about the Young's modulus. Okay, so there you will be available with this kind of terminologies, that is elastic deformation and plastic deformation. You will be coming against the yield point and proportionality limits and rupture limit and all such kind of things are available there. So uh, before moving ahead, it's better if you grasp the stress strain curve also. Next definition is strain hardening. Now whenever you are available with the load on, or whenever you are applying the load on the material, after yield point, there is a point which is called as the yield point available on that stress strain curve. Recrystallization is not possible. Okay. Second point, the crystals, all different kind of crystals, they are available with some kind of defects, crystallographic defects. This is called as the dislocations. Now these dislocations are capable of moving along with the slip plane. And who will make them move? The force which you are continuously applying. So when you go on applying the force, these dislocations will tend to move along their slip plane. And a point will come where these dislocations will pile up. They will group together. So once this piling up starts, the movement of other dislocations become very difficult. Okay, that means you are not able to move. That means this piling up is now offering very high resistance to other dislocations. Okay, so what you will do, obviously you need to apply more force to deform the specimen, to deform the material. Okay, that means in other terms you can say that the stress which is required to move these dislocations will increase, means the requirement of the stress will increase. Okay, so this phenomena where the requirement of the stress will increase due to the piling up of the dislocations is called as the strain hardening. Okay, it is also called as the cold hardening. The reason is that it is done at a room temperature. Okay, so whenever at a room temperature you are applying force beyond yield point, the dislocations are available in every material. These dislocations will pile up and they will start offering a high resistance towards the load which you are applying, and that's how slowly and gradually this piling up of the dislocation will offer a very good strength to the material. This process, this phenomena is called as the strain hardening. So these are the few definitions which will come in your way. So remember them. Now let us start with our subject. So metal forming is a very important manufacturing process, and why it is important, the reasons are mentioned here, because it is highly cost effective from the industry point of view. You can change, improve the material properties of the specimen. Very flexible operations can be equipped. You can get very high productivity, and thus there will be material saving available to you. Now in your day-to-day life, you are available with various kind of equipments, components, things, engineered parts, you can say. These components, or these you can say things, are made up of some small other components. For example, if you take the example of a tube light, or if you take example of a fan. So fan again is made up of, it is not made from one complete piece, it is made up of a group of components. So blades are manufactured different, the motor is manufactured by different manufacturing processes, the rod is manufactured by different manufacturing processes, the wire which is used to provide current is manufactured by different processes. Okay, so when you club all these things together, it will form a complete unit which is called as the fan. Similarly, let us take the example of a small pan here, which is a widely used component in our day-to-day life. So pan is made up of different components. So here you can see in the slide, barrel is there, then there is a tape, coil spring is available, refill is available, and on the end there is a thrust device, that is where you apply the thumb and you push so that the refill comes out. So these all components are made up of by different manufacturing processes. And once the components are clubbed together, they form a pen which is available for your writing purposes. Similarly, second example is of a car. A simple car is made up of more than 30-100 parts on an average. If the size of the vehicle increases, obviously the number of parts may also increase. So here you can see tire manufacturing process is different, the rim manufacturing process is different, the seats manufacturing process is different, the you can say stamped bonnet is there, doors are there, roof is there, floor is there, there are different shafts available to us, nut and bolts are equipped, suspension system is there, different engine is there. So there are different components which are made up of by different manufacturing processes. Okay, so production means you are producing all these components. What does a production mean? What happens in a production house? So production involves all different type of manufacturing processes. Production involves manufacturing processes. So manufacturing, what do you mean by manufacturing? Manufacturing refers to just the conversion of raw material into the finished goods. Okay, when you convert raw materials into the finished good with the help of certain techniques, that is called as the manufacturing. Okay, so now the question arises is how to select those suitable techniques. Okay, so the selection includes the selection of material and the equipment. Once you are available with the right kind of material and right kind of equipment, then you can select suitable manufacturing process, suitable manufacturing technique. And apart from it, how to select the material and equipment, what points you need to take care. The first is the cost of production. What will be the energy consumption? Obviously, it has to be the minimum. And what are the environmental impacts? Okay. So once you are available with the answers of these three questions, basically, okay, these 3 points, you will be selecting your material based on these and the equipment based on 3 points. And then you can finalize what kind of manufacturing process you are going to use to manufacture your product. So keeping all these things in mind, there are different manufacturing processes are available to us in industries. So manufacturing processes are classified in various, you can say, subcategories. That is, the joining is there, shaping is there, forming, modification, coating, dividing. There are different manufacturing processes are available to us. In automotive industries, aerospace industries, defense, and other industries, they are widely used. Just for an example here, what are the formed parts? Forming is one of the manufacturing process which we will be targeting here because our subject topic is about the forming. Okay, so that's why we are concentrating more here. So forming is basically a process which finds its place in automotive and aerospace defense industries. Some of the examples which in automotive industries of automotive industry components are rims, car body, valves, chassis, oil pan. On all these different kind of components are made up of with the help of the forming process. In our day-to-day life, your cooking vessels, toothpaste containers, bicycle bodies, and all these kinds are also made by the forming processes. Okay. So what do you mean by forming process? What actually does this mean? So forming is basically a process of obtaining the desired shape and size, okay, on the raw material by subjecting it to the plastic deformation. I hope you understand what is plastic deformation now. So forming is the process of obtaining the required shape and size by subjecting your workpiece material to the plastic deformation through the application of force. That force can be tensile, it can be compressive force, it can be bending or shear force, or the combination of all these forces. So when you apply the force up to the plastic deformation limit, you will get the change in the shape. This definition is called as, or this whole process is called as the forming. So here you can see the forming is subcategorized into different parts. There can be bulk forming, sheet forming is there, powder metal forming is available. So bulk forming, where with the help of continuous casting process, you are creating ingots, and from these ingots, various kind of blooms and billets are being made, and from these blooms and billets, you slabs also, you can create different kind of pipes and different kind of bars and eye sections and all, and these will be further processed. That is, the secondary operations will be carried out, where different end used components will be made with the help of these different processes. Okay. So the next category will be your sheet forming, where metal sheets are available, and in automotive industry, these all manufacturing processes are very much important. Okay, all deep drawing and blanking and piercing are widely used to manufacture different sizes of components. So broadly, if you see, bulk forming and sheet metal forming are the two different categories of the metal forming processes. So bulk forming refers to the use of raw material which have low surface area to volume ratio. Okay. So rolling, forging, extrusions, they are all the categories, subcategories of the bulk forming. And here the nature of force will be different. You can either use tensile force, you can use compressive, or you can use the combination of these forces. Okay. So there is a set of tool and die is used, and this set of tool and die will be helpful to create the change in the shape, or you can say to form the material, to deform the material. Okay. Second is sheet metal forming, where a simple kind of sheets are used to change its shape and to convert it into the final used products. So tensile or shear force can be used on the plates and the strips. Again, punch and die press is been used, which can be hydraulic or pneumatic. We will see in the coming lecture series what are the different kind of presses are being used. Okay, and some of the processes which lie under this categories are bending, drawing, shearing, blanking, and punching. Okay, so based on the nature of deformation force applied on the material, okay, there are this is a kind of a classification. One classification you have already seen, based on the manufacturing processes. Here the classification is done based on the force which has been applied. So when forming is done by the compressive stress, it is open die forging, closed die forging, rolling is the coining, extrusion is been done. Okay. Next is tensile and compressive stress, bending and shearing stress, forming under tensile stress. So there are different kind of forces are been here. So forming is also classified as cold forming, hot forming, and warm forming, that we'll see later on. What are these things look like? So hot forming is basically when the temperature, it is done at the high temperature, that is a recrystallization temperature. Okay, so when recrystallization temperature is, then forming is carried out at above recrystallization temperature, it is called as hot forming, and when it is done below it, it is called as the cold forming. Okay, so basically the recrystallization temperature for various material ranges from 0.5 to 0.8 Tm. Tm means the melting temperature. So moving ahead, uh, we'll you can say understand more about this cold forming. So cold forming is defined as the plastic deformation, and the temperature, as we have already discussed, that it is below the recrystallization temperature. Okay, so plastic deformation takes place at a temperature which is below recrystallization temperature, then it is called as the cold forming. And here is where the strain hardening happens. So when we were discussing about the definition of strain hardening, I have told you that it is also called as cold hardening or cold working. And here the strain hardening takes place, that is the strength of the material is improved. Okay, so once this strain hardening takes place, or when strain harden, more and more force is required to cause the plastic deformation. Okay, so after some point of time, if let us say if the strain hardening capacity is not removed, then the cracks may also start, and the metal can fail, your material, your specimen can fail. So in a way, strain hardening is good, but beyond certain limit, strain hardening can create various problems also. Next is hot forming. So hot forming is the again plastic deformation, and it is done above the recrystallization temperature. Yes, recrystallization temperature. So again, if not done properly, then it may create various other problems. But here, what is the advantage of hot forming as compared to the cold forming is that the hot forming provides a fine-grained recrystallized structure. That is what the advantage, where you get a very fine-grained recrystallized structure in a hot forming. Okay. So recrystallization temperature is not a one fixed temperature; it is basically a range of temperature. So we have already discussed this thing. I mean, so you are coming against this term recrystallization temperature again and again. So this is basically the range of the temperature. Okay, and its temperature, I mean, so what factors affect this temperature is, first is this nature of metal or alloys. Okay, second is amount of cold work which has already been done, and third one is your strain rate. Okay, so these are the three basic factors which affect the recrystallization temperature of any of the material. Okay. So recrystallization temperature of low melting points may be taken as room temperature. Okay, and the effects of strain hardening can be removed by annealing above the recrystallization temperature. So let us say, as discussed in the cold forming, if you are not able to remove the strain hardening, then the cracks and failure of the material may start. So that can be removed by the annealing process of which you can carry out after completion of the forming process. Okay. So this is what the basic difference between cold forming and hot forming. Uh, uh, you can understand major things we have already discussed. These are just kept in a tabular format. So cold working is done at a room temperature. Uh, the benefit is that no oxidation will take place, so no scale formation will happen here. Whereas this is not the case in a hot forming. Hot forming is done above recrystallization temperature, and there can be a partial decarbonization of the workpiece. Okay. Second difference is dimensional accuracy and bright surface is available to us, and that's the reason why when you cold roll steel bars, they are called as the bright bars. As because heat is available to us in the hot forming, so they create very dark surfaces. Okay, and this cold the steel bars, they are called as the black bars. Okay. Third point is heavy work hardening will occur. Okay, that is the strain hardening will occur in your cold forming processes. Okay, which improves the strength and hardness of the bars. Okay. But apart from it, there is one again disadvantage of this strain hardening is that as we have already discussed, that it will require more force to deform once the dislocations are piling up. So there will be an increase in the energy consumption. Okay, whereas to remove this point, that is to to reduce the energy consumption, people generally go for the hot forming. So strength of the material reduces at high temperature, but yes, malleability and ductility improves. And very low capacity equipment can be used for hot forming because now the forces which are required to deform the metal are less. Okay. Now, due to limited ductility at the room temperature, now here the ductility will be a problem. Uh, so production of complex shapes is not possible because the strength is going on increasing as you are applying the more and more force. Okay, so that is not the case in a hot forming case. In a hot forming, because production of complex shapes is possible because here you are already applying the temperature, so malleability and ductility is very good, and thus you can easily create the complex shapes of the components. Several internal stresses can be induced in the metal during the cold working. Okay, so different kind of stresses may be induced here. Here no residual stress is there, and the mechanical work structure is also good. We have already discussed the grain structure, fine grain structure is being created uh, when you go for a hot forming kind of things. So this is what the advantages kind of thing. Okay, so this was what the difference between the cold forming and hot forming. Depending on your requirement, you can select these uh, processes. Okay, based on your application. So next stamping topic we will cover in the next lecture. Today till here, you just read out again this whole video and try to understand the basics, try to grab the things here, and we will meet again in the second video lecture. Thank you very much.